everyone. I'm Linhua. I'm a big fan of Knowledge Graph and Neo4j, and today I'm going to talk about real-time knowledge graph for documents with LLM. And I can hear my echo. I'm not sure how to. Can you hear my echo? Okay. I'll just continue it this way. So today we're going to talk about real-time knowledge graph for documents with LLM. We will be looking at an example and how can we extract entities from a set of documents using LLMs. So entities are like a terminology, and then how do we use LLMs to extract relationships between entities? And then we will generate relationships between the entity and the document itself. And then we export it to Neo4j for context engineering. So a quick note, today we're going to use Cocoa Index. Cocoa Index is used for data transformation to build a knowledge graph. It is designed for AI workloads, works with LLM. It is built for continuous context engineering for AI agents, and it has exceptional synergy with Neo4j. And so since we're going to do triple extraction and port it to Neo4j by real example today, first let's quickly scan through the terminology. The most two important terminology here today are nodes and relationships. So nodes are used to represent entities. So for domain, for example, this node, some hacks is a property, and then you have node labels. So in property graph, node labels are used to define the type of this node. So here, this node label is a person. And next, we're gonna look at the relationships. So like person acting movie is kind of a relationship. In the property graph, a relationship can have exactly one relationship type, which is acting, and it can have properties as well. So let's jump into the example we're going to take a look at together today. So today we're going to take a look at how do we turn a set of documents. And in this example, we use the design documentation, with a lot of technical terms. And then we sort of start to use LLMs to extract the relationship between the concepts in each document. And then we will try to generate two kinds of relationship. So first relationship is like we extract different terminology from a document. And for example, if we say, in this document, Cocoa Index supports incremental indexing, then it generates two entities, right? You have Cocoa Index, you have incremental processing, so they are like terminology we extracted by LLM, and then the relationship is supports this. And then another kind of relationship we want to use is because we sort of want like citations. Where are these kind of terminologies coming from? So this another kind of node is like document node that contains different kinds of terminologies. And so we'll just look at how we do that. I try to simplify this with like a data flow and some key code samples. So first we will just use a framework to load a bunch of local files and add them as source. So next step is once we ingested the set of local files, we're going to use LLMs to extract the, like for each document, we'll do a basic summary and a title, and we generate this sort of document node. So the way to do it is essentially, like the problem is all about how do you do effective structured extraction, and then how do you make it to Neo4j nodes with minimal effort. So here, like we're looking at like how do we processing documents, and we generate a document node. So we first will define like a Python data class, like document summary title, data summary, right? And then we will call this extract by LLM function. And once we do it, it will return us like structured information about okay, for each document. These are the title, this is a summary, and to help you understand what has happened. So this is what the data look like. For example, I have a file that is to describe total index CLI. And after the LLM extraction, it becomes like, okay, I have like title, then I have a summary. So the next step is, so we'll just leave it there, like it's, we'll leave in the table and we'll map it to Neo4j in a minute. So the next section we will do is, okay, so now we have all the documents loaded, and for each document, we actually want to extract all the terminology out and the relationship between the terminologies. Like we usually call this like triple extraction, which is a kind of a structured extraction. And of course, you can also load like a set of preset terminology and only use triple extraction to extract relationship between these terms. And so the way we do it is very similar. It's like first is the structured extraction problem. So first we define the structure for the triple extraction. So you see, this is like a very standard way. Like you have usually you have a subject, and you have a predicate, and you have an object. So predicate is usually like, okay, what's the relationship between two entities? And then say describe relationship between two entities. Subject is probably like total index concept. And then, yeah, predicate is relationship. And then you just call the extract by as well, very similar. And then it will give you this subject, predicate, object to give you a more concrete look about what does this mean. So let's take a look at the data. If we have time, I can do like a live demo as well. So for example, here we're loading in the content of indexing basics. This is like a file. And then after this LLM extraction, for this file, we have actually extracted the following, it's like a new subtable. And then you have subject, predicate, object. So for example, you have extracted these terms, index flow, predicate, like is managed by data. Cocoa index is a ETL framework. So it sort of starts to forming this set of terminology and the relationship between terminology. So we are pretty much done with all the data extraction part. The next part is, okay, so we have this set of data, the structured data, how do we map them to Neo4j? So Cocoa Index actually it's like very natively connected to Neo4j. So you only need to do very simple export and the data mapping, and you have the Neo4j ready. So to build a knowledge graph, if you look at here, there's like you have as we see the terminology extracted from earlier, for example, you have Cocoa Index supports incremental processing. Cocoa Index belongs to ETL framework. Once you map them to Cocoa Index, it will naturally be duplicated by the primary key, and then it will become like Cocoa relationship with incremental indexing, ETL framework. So you have this relationship ready, and all the nodes for Neo4j need two things. First is label, which is like type of the node. So it can be like, I have, in this example, I have two kinds, right? One is the document and one is the entity. So entity are like all of these terminologies. And I have primary key to identify different nodes. So let's take a look at how do I map these structures to the Neo4j. So once you have like collected the data in a collector, what you will simply do is, okay, so I have this document node collector. Then I just export it to Neo4j with a mapping to the document node, and the primary field will be the file name. So what does this do is it exports Neo4j node with label document from the document node collector. It declares Neo4j node label document, specifies file name as primary key field, and it will automatically carry all the fields earlier you collected as attributes to the Neo4j node. So the next step is we're going to export the relationships. So here is the same. So the way you convert this structured extraction to Neo4j node is you simply call this export function, and with a mapping code, like say, I'm going to export the entity relationship, and with the source that comes from the entity. So basically this one does is I'm going to create node from this field. I give it a label entity, and then I'll do some field mapping. So it will automatically carries the structured extraction to the new 4J and carries the properties over. So as you see here, like when we're doing the entity relationship, we usually have source and the target, and then the relationship will be generated on the way. So finally, we are going to extract the relationship of which concept is cited by which document. So which is very similar. So I will skip this since we have a limited time. And finally, you can spin over a new Neo4j instance and give it a try. And so just one last slide is the simplicity of this flow is the way you map the structure mapping to Neo4j is you only need to declare data mappings, and CocoIndex takes care of all the rest to make a graph in sync with the source data. For example, like create index, generate various cipher queries, which to me is kind of painful to build, and update and delete it. For example, if you have the source and it keeps changing, and then you need to update some source change, you don't have to like recompute or like do specific cipher query about it, which creates a condition for if you want to build AI agents and you want to do this continuous context engineering around it, it can be very, very handy. So I think it's about time. I probably won't have time to do a live demo, but if anybody wants to see it, you have my LinkedIn and we can schedule a meeting for like a demo.